Now I have the mic on this side, I'll turn up the volume, and then I can start talking into it, and you can see that it actually works. It's a megaphone. Wow. I built a megaphone using BJTs. It turned out to be a lot more challenging than I thought, and I learned several important lessons in BJT design that I had never thought about before. Here's how it went. So most of my older circuits got snapped to dust. I don't know where they are. Honestly, looking back through my notes, I feel like an archaeologist trying to decipher cave paintings. So a few circuits in, I thought having two Class A amplifiers would give me more gain than a Darlington, which I think is misguided, but not wrong. By having two Class A amps, I was able to multiply the input voltage by using two collector resistors instead of one. Although, to be honest, I could have just increased the collector resistor value in the original design if I had wanted some more gain. So this design gave me the signal I wanted. It amplified the mic. But the issue is that when I connected the speaker, it would collapse the waveform and it'd be barely audible. So it was at this point I realized I neglected current in my design. I was able to get the correct output voltage, but I naively assumed that the Class AB amp would make up for any lack of current that the Class A portion wasn't able to do. I needed to rethink how I was approaching this. So onto the Class AB. The diode ladder did not work. I would get thermal runaway, which is when transistors heat up, which reduces the required VBE, which causes more current to go through them, increasing the heat, and the cycle continues. This cycle will destroy the transistors if left unchecked. So instead, I used the VBE multiplier. You thermally couple all three transistors. When the transistors heat up, the VBE multiplier will reduce the voltage across it, which causes less current to go through the transistors. So that brings us to the important lessons I learned while making this megaphone. 1. Consider your starting and ending current/voltage constraints. So I didn't have an exact output current or voltage I wanted, so I just chose around 150, 200 milliamps. With an 8 ohm speaker, that would be around 2 volts. However, my mic was only capable of providing 4 microamps and around 4 millivolts. So, I needed to make sure I had enough gain in my design, which with the two transistors of the Class A, assuming 30 per transistor, that's 900 gain for the Class A, and the Class AB would be around 20, so I approximated I have a max gain of around 18,000, which is far beyond what I need, which was around 2,000. 2. Current sharing between stages. So if you're connecting different amplifier stages, most likely you're going to be AC coupling them, which would be this part here. The thing is that not all of your current is just going to take the path of the capacitor, because capacitors have impedance at different frequencies. So what it actually looks like would be this. Instead of a capacitor, you model it as a resistor at whatever frequency. Because of that, if you have a limited amount of current, so when you design a Class A amplifier, you decide how much collector current there is. That does set an inherent cap on how much current you can really get going through this system. So because of that, the amount of current that can flow through the capacitor has to get shared with the current that's going to be flowing through the transistor. And if you don't give it enough room, then that current sharing can actually be really detrimental to your design. It can cause a collapse of the signal or just not even enough driving current, stuff like that. 3. Add in headway for voltage and current. The third point is setting up enough headroom. So you may already be familiar with voltage headroom, which is an easy example would be a Class A amp. So for a Class A amp, when you set the DC midpoint to be half of VCC, that's you adding in voltage headroom. You're giving the signal equal space on both sides to go up and down. For current headroom, another way to think about it would be like giving yourself extra capacity to drive current. So if you wanted to drive 10 milliamps at your output, I wouldn't decide my collector current to be 10 milliamps because I know that not all the current is going to be able to go that way. So instead, I might choose something like 20, 30 milliamps of collector current. So that I know that there's excess current and that it can take that path despite the impedances in current sharing. Last thing was for me to take these electronics, give them mobile power, and put them in housing. One major concern I had was power. Since instead of a bench supply giving me 12 volts, I would need to get 12 volts from batteries somehow. So I bought a 12 volt battery. I did my modeling using the amateur SolidWorks license, which, thank you Emily the engineer, she had a short about that, which let me find out that that's a thing. No more FreeCAD for me. I then 3D printed the parts and I assembled. Moving the circuit to protoboard was its own whole can of worms too, with like weird noises, shorts. I won't go too much into detail, but let's just say I just kept adding ground wires and eventually it worked.
Thank you for watching.
If you're interested in more videos like this, please hit the subscribe button. I'm working on my next project, which I haven't decided yet, but it'll either be something with motors or something wireless. So we'll see how that goes. But yeah, see ya.